Well, looks like I'm back having to talk about AI security one more time because we are getting way more breaches nowadays thanks to AI coding. Everyone seems to be using AI to code faster, and I do this too, but it seems like almost nobody is realizing that AI is also making the hackers trying to break your code every single day faster as well. So I wanted to create this video to talk you through the top 3 ways that AI is making criminals faster right now and how you can become a security engineer to make software safer for everyone. Just a couple of weeks ago, hackers poisoned a Visual Studio Code extension called NX Console that has over 2 million full installs. Now, even though this poison extension was patched very quickly, in just a few minutes, this kind of attack is able to steal credentials from dozens, if not hundreds, of devices, especially because most devices seem to auto-update these extensions. And this can lead to leaked credentials, leaked secrets, leaked source code, and all kinds of personal information being held hostage. Similarly, there was a supply chain attack on TanStack dependencies, which are great front-end dependencies that I also use for plenty of projects. Now, it's important to realize that these kinds of attacks are not really new, but with AI-powered penetration tools, it is much easier for any incentivized attacker to scan and pressure any open source project that is used by companies today. Now, the great part here is that we can learn quickly. In NX's postmortem, they describe the fix that you can apply today. The single most effective fix is to vendor your dependencies. This means pinning them at specific versions from specific sources. In addition, you want to disable auto updates for apps, extensions, and packages until a release has been out for a reasonable window of time, because this delay gives maintainers time to catch and pull a poisoned version before it ever lands on your machine. Threat number 2 is the code that your own AI coding tools are writing for you right now. Veracode's Spring 2026 update tested more than 150 large language models on 80 coding tasks across a variety of programming languages, and 45% of the AI-generated code still failed security tests, with Java even failing 71% of the time, with a lot of cross-site scripting prevention failing in even more cases. You might not be familiar with all these failure modes, but the main learning here is that the passing rate has not really moved in 2 years, even as the models got better at everything else. Now, some people might say, hey, what about the 10x AI coding speed that every founder loves to, brag about? Well, the problem is that this metric doesn't really work for real production code with database migrations, transaction layers, and live users. Coding super fast just seems to create the vulnerabilities that hackers will weaponize very soon. Anthropic, of course, also previewed Claude Mythos that autonomously hunts for these vulnerabilities and writes working exploits for them. But this is not a public model yet, so we are leaning on the lab's own stories rather than a lot of independent testing. The real practical concerns will probably become clearer over time. Now, even here, the preliminary findings kind of point the same way. Adversaries with AI assisted tools can move a lot faster than the people patching behind them. Because when you're trying to break a tool, you can try thousands of things, but when you need to fix a tool, there's only a couple of right solutions that you need to validate and test for. So when there is pressure in the industry to use AI code for everything, this can start to feel impossible. Instead of leaning on real power, you move the check off of the engineer and into the pipeline. You can run automated security scanning on every AI-generated change before it can merge, block anything that comes back high severity, and give your coding agents the least access they need to do the job. And of course, never write directly to production, which somehow still is happening in 2026. The review will still happen on every line, but then a machine will enforce it on the way in, so it doesn't become dependent on just a tired engineer remembering to look at a specific release note under a deadline. Now, unfortunately, I'm describing a nice theoretical solution, but most of the time, the solution that you can actually apply today are AI review tools, which have their own limitations. But using them is better than nothing. Threat number 3 is AI-powered social engineering. Hunt ran 70,000 phishing simulations per round against 2.5 million users, and in March 2023, a long time ago, their AI-generated phishing was 31% less effective than their elite human red team. By March 2025, though, that same AI was 23% more effective than the same human red team. Here, too, the difference is not that the method of social engineering is new per se. However, AI writes fluent, tailored phishing at scale. So the lures that keep landing in everyone's email inbox keep getting better and just arrive more often at the right time. And you cannot just train employees out of this anymore because the same AI already beats the experts that you would train your staff against. Usually, the fix here would be to stop relying on people spotting the lures and remove the thing being phished in the first place. So, what do I mean by this? Well, instead of just having a username and password for all your services, you want to introduce phishing resistant MFA like passkeys and hardware keys that don't care about how convincing the email looks because there is no password for an employee to hand over in the first place. There is a real physical presence that will prevent most phishing attempts. So you have three things hitting every engineering team at once: supply chain worms, AI tools, and AI generated phishing that can beat elite human red teams. And the people supposed to stop all three are starting to really burn out. Security leaders are working far beyond their contracted hours, and CISOs now turn over so fast that the person who signed off on all of the AI rollouts last quarter is often gone before the next breach even lands, which just puts way more pressure on the next generation of security engineers. And meanwhile, the global cybersecurity workforce is missing at least 4.7 million people. The defensive side, especially, is badly understaffed, and this is where the AI security engineer can come in. The people already doing this kind of great work didn't just follow one path. A couple of examples: Johan Rehberger built red teams at Microsoft and Uber, started the blog Embrace the Red, and now independently red teams AI tools like Copilot, Gemini, and Claude. Joseph Tacker spent his early career in blue team detection, moved into SaaS security, and is now a Google Most Valuable Hacker for AI products. Rich Harang did research at Sophos AI and is now principal security architect at NVIDIA, where he coined the AI kill chain. And all of these people published real work that proved that they could break and defend real AI systems. So if this story and these people inspire you to help defend software against attackers, then the great news is that you can start your own AI security career this weekend. You can start by reading the OWASP LLM Top 10, build a vulnerable AI agent on purpose, and then red team it with Prompt Foo and NVIDIA's Garak. If you have never built an AI system end to end, well, you have to learn the fundamentals first because you cannot really attack what you cannot build. Now, you can also grab my free local AI projects, which are in the description down below, which are the exact starting points they give engineers who are building portfolios for AI engineering roles. If you grab my projects below, you can get started with your engineering security journey today. So I look forward to seeing your progress.